This is problem number 21 from section 1.8. I'm going to do this in two parts. In part one, I just want to talk about the setup and the approach to this problem because it is a little bit different than what you've seen before. Again, we're working with a linear, non-homogeneous problem of the form dy dt plus some constant a times y. And on the right-hand side, though, I want you to think that we have two different types of non-homogeneous terms. What we do. One of our terms, one of our b sub 1's, one of our b terms is a polynomial, the polynomial t squared plus 2t plus 1. The second non-linear term is an exponential function e to the 4t. Because of linearity, I'm going to demonstrate that that we can find the particular solution to this non-homogeneous problem by adding together two different particular solutions. So its linearity gives us that the particular solution that we're going to use can be just a sum of two specific ones, one that will solve the problem when B1 is the right-hand side, and the other will solve the problem when B2 is the right-hand side. So let me show you what I mean. So I'm going to let y sub p of t, p1 of t, be a solution of this differential equation, dy dt plus ay is equal to b1. That means that this equation is true. If I take the derivative of p1 and add it to a times y of p1, I will get the function b1, because that's what solutions of this differential equation do. Okay. And similarly, I let y p sub 2 of t be a solution of this differential equation, which is equal to b2 of t. And that means that if I were to differentiate y sub p2 and add it to a times y sub p2, I will get the function b sub 2. I'm going to go to the next page. So, what we have is, if my solution y of t, my particular solution, is just a sum of these two, p1 of t plus p2, let me erase that, make that prettier, p2 of t, that this will solve the non-homogeneous problem with the right-hand side of b1 plus b2. And so what we do is we say the following. Here's y sub p plus a y sub p. But that's just the sum of two functions. Y sub p1 plus y sub p2. That's a times y sub p1 plus y sub p2. The derivative of a sum is the sum of the derivatives, dy sub p1 dt plus dy sub p2 dt plus a y sub p1 plus a y sub p2. And grouping them together, I have dy sub p1 dt plus a y p1 and dy p2 of t plus a y p2. But on the previous slide, I showed that that this equation adds up to be b1 of t, and this equation, being a solution of the equation I showed in the previous slide, this equation adds up to be b2 of t. And so, the way we're going to solve our differential equation is to do it and find our particular solution in two parts. And in the next video, I will do each of those two parts separately. Okay? Thank you.